Hello everyone, myself Dr. Ranjit Kumar Gatla, working as an associate professor in the Department of Electrical and Electronics Engineering at Institute of Aeronautical Engineering. So in today's class, we are going to discuss about some definition and terminologies related to the two-port networks. So here we know already we have discussed what is meant by the two-port networks, or what are the various two-port network parameters, and what are the applications of these two-port network parameters, and what is the interrelation between these two-port networks, and what are the interconnections of the two-port networks. So these are the various topics that we have already covered in our previous classes. So in this class, because here the definition and terminology is very important for any particular topic, because we should understand basics very clearly. So that is why here the definition and terminology concept is very important in all the topics. Of course, we have already covered some of the topics, the definition and terminologies. And now, in today's class, we are going to cover in the two-port networks, which means, in another words, we are going to discuss once again the basics of the two-port network parameters, which means what is two-port network, So like that of kind of things, we are going to discuss in this today's class. So first of all, what is two-port network, right? So we know the two-port network is nothing but which will having the two ports. One is the input port, another one is the output port. So a network which is having the two ports is nothing but the two-port network, right? So here, as you can see here, the input port, let us consider, are the input terminals. In other words, port is nothing but the terminals. So the input terminals 1 and 2, so which means here we are just representing the input terminals as a 1 and 1 dash, and the output terminals 2 and 2 dash. So the two-port network, a network having the two ports, one is input and another one is the output, then that particular network is called as a two-port network, right? And here, as you can see, as I have mentioned, because why we are going to the two-port network, right, instead of the general electrical circuits or electrical networks, right? So, a circuit in such a case, like the amplifiers and filters, can be modeled by a two-port network for the simplification, because for the filter also input and output is there, right? So for the amplifier also, we will give some input signal and then we will get some output signal for the amplification purpose and for the filtering purpose. So in these two, in these kind of networks, we usually go for the two-port network, right? So of course, then the two-port, we cannot simply define a network which is having the two ports, one is input and another one is the output port, right? Then we should discuss about the variables of this two-port network also. So which means the variables which are related to the input side, which means the port 1, and the variables which are related to the output side, which is the port 2, right? So the variables which are related to the port 1, of course here we usually consider only the major variables, because in case of amplifier and the filter circuits, so what are the variables, that are very important to control the input or output signal, so those kind of variables only here we will consider. So here, when coming to the input side, the voltage V1 and the current I1 is the input side. And when coming to the output parameters, the voltage V2 and the current I2. So which means here, the V1 is the voltage across the port 1 are the primary terminals, and then the current flowing through this particular terminals is, let us consider, I1, right? Then similarly, here the output between the second port is V2 and the current flowing through. Of course, here the direction may be towards or away. Let me write just like this, because the direction and all, there is again another topic. So we will discuss in detail later. Let us consider I2, right? Then how we can model this two-port network based on the relation between these parameters. Because as we know, there are various two-port network parameters like Z, Y, ABCD, H, like these parameters are there. So then how we can differentiate these parameters means based on the relation between these input and output parameters. Based on these input and output parameters, we can differentiate the various parameters of the two-port network. Right? So of course, here as we mentioned, there are 6 different ways describe the relation between these variables. Okay, so depending on which 2 out of 4 variables are given, so while the other can always be derived. So which means based on this relation between these parameters, so we can we can differentiate or we can describe the various two-port network parameters, right? So which means what is two-port network? The two-port network having a network having the 2 ports input and output parameter, or 2 ports, one port is input side, another port is output side. And in the 2 ports, okay, for the input side, we usually consider the input parameters are V1 and I1 and the output parameters are V2 and I2. So based on the relation between the input and output parameters, so we can define the various 2-port network parameters. So that is what about the 2-port network, the basic definition of the 2-port network, right? Then, yeah, that's what, of course, as they have already mentioned here. Yeah. Then coming to the next question, what are the 2-port network parameters? Before it was, what is 2-port network? Then what are the 2-port network parameters? Because as we discussed in just now, so based on the relation between input and output parameters, okay, are based on the relation among the 4 parameters, V1, I1, V2, I2. So we can define or we can derive the various 2-port network parameters. So what are those various 2-port network parameters, right? So as they mentioned, there are different parameters need to analyze the 2-port network, because of course all these parameters we are using to analyze the 2-port network. Analyzing is nothing but, okay, so how we can control the output based on the input parameters, or how we can control the input based on the output parameters, like that. Okay, so which means here if the network is linear, that is each variable can be expressed as a linear function of some 2 other variables, then we have the following models. So here the 2-port network models are Z parameters. We can also call it as a impedance parameters, or the type of modeling the 2-port network is called as a impedance model. Then the second one is the Y parameters, or we can also call it as a admittance parameters, or the model that we are designed based on these relations, then we can also call it as a admittance model. Then ABCD model, or we can also call it as a transmission parameters or transmission model. Then H model, or we can also call it as a hybrid model. So these are the 4 basic 2-port network parameters based on the relation between the or the relation among the parameters present in the 2-port network. Then here now we are going to discuss one by one. So what is Z parameters, or what is Y parameters, and what is ABCD parameters, and what is H parameters. And also we will discuss what is the relation between these parameters, which means the relation between Z and Y, or Z and ABC, or Z and H. Similarly, the relation between Y and the other parameters, like that also we will discuss here. So first let us go with the Z parameters. So what is Z parameters, or the defined Z parameters? So here for the Z parameters, of course we know already. So the Z parameters is also known as the impedance parameters. The Z parameters also known as impedance parameters. So when we use the Z parameters for analyzing the 2-port network, the voltages are represented as a functions of the current. Okay, so here this is one of the key point. So in Z parameters, the voltages are represented as a functions of the current. The voltages are represented as a functions of the current, right? So that is, based on these voltages represented as a functions of the current is called as a, or is defined as a Z parameters, right? Of course here For each different types of parameters, we will be having four different kinds of parameters like Z11, Z12 and Z21 and Z22. So like that here, which means here how many voltages are there? One is the primary side, another one is the secondary side. So which means V1 and V2. So V1 is representing as a functions of the current, means what are the currents I1 and I2. Similarly V2 also. So that's why here V1 is equal to a function of F1 and I1 and I2, and V2 is equal to a function of I1 and I2. So then if you simplify furthermore, or if you represent the same thing in this pictorial form or in the network form, okay, then here we know already this is I1 of S and V1 of S, I mean for the primary side, and the secondary side here it is I2 of S and V2 of S, of course, and then we can define here V1 is equal to functions of I1 and I2, and V2 is equal to function of I1 and I2. Right. So if they ask us to, what is, suppose if you get a question, define the Z parameters in a network oriented, then you can draw this picture. Okay, you just write this definition, of course, then just draw this picture, then it will be fine. Which means if you are able to draw this picture, then which means, okay, so you understood the concept of Z parameters, right? Then if you simplify this furthermore, then how we can write exactly the functions of I1 and I2 is nothing but, so the equation V1 is equal to Z11 into I1 plus Z12 into I2, and similarly V2 is equal to Z21 into I1 and Z22 into I2. So here the Z11, Z12 and Z21, Z22 are the four impedance parameters of a given two-port network, right? Then if you furthermore simplify this, or if you can write the same equation in the matrix form, okay, so then here V1, V2 is equal to Z11, Z12, Z21, Z22 into I1 and I2, or in simply, so this we can, write it as a Z. So which means here Z is equal to Z11, Z12 and Z21, Z22. So that's what we have, just we replace with the Z into I1 and I2. Then here, what is Z11 and what is Z12 and what is Z21 and what is Z22? So that is also very important. I mean, when we can find the Z11, right? So, and another thing, this is also called as the open circuit parameters. Okay, yeah. So here Z11, which is equal to input impedance keeping output open. Okay, so when you can find Z11, that's what I mean. I just now I told you, these are also called as a open circuit parameters, which means we will find the parameters related to the primary side by keeping the secondary side as an open circuit. Then similarly, we will find the parameters related to the secondary side by keeping the primary side as an open circuit. So that's why these Z parameters are also called as not only just the impedance parameters, are also called as open circuit parameters, right? Yeah. Then input impedance keeping the output is open. So which means here I2 gets 0. So that's we can get V1 by I1 Z11 is equal to, right? So because if you make I2 is equal to 0, I2 is equal to 0 from this equation, in this equation, so this term will get 0. Okay, if you send here the I1 to this side, then you will get the Z11. So that's what here Z11 is equal to V1 by I1 when I2 is equal to 0. Then Z12. So Z12 is reverse transfer impedance. Okay, reverse transfer impedance keeping input is open circuit, right? So which means here Z12 is related to the secondary side. Okay, so that's why here, then in this case we are making the input side or the input current is equal to 0, which is nothing but the input terminals are open circuit. So again in this equation, if you make I1 is equal to 0, then this term will become 0. Then here you just send I2 this side, then V1 by I2, which is Z12, right? So V1 by I2. Then coming to the another parameter, which is Z22, which is equal to output impedance keeping input is open. Okay, so in the by using the second equation. So here again, if you make I1 is equal to 0, then this total term will become 0. Then send I2 this side, then Z22 is equal to V2 by I2. Right. Then similarly, if you want Z21, Then this is also called as a forward transfer impedance by keeping the output terminal as a open. So in this case, again, if I2 is open, then this whole term will become 0. Then if you send I1 to this side, then V2 by I1, then this is Z2, right? So this is how we can find the the impedance parameters. So once you get understood to find the impedance parameters, then it is very easy to understand the remaining parameters also, like HY and HY and ABCD, right? So here, of course, you may get the question, define input impedance of a two-port network. Then the input impedance, when you will get the input impedance is defined when keeping the output is open circuit, or the input impedance is defined as the ratio of input voltage by the input current when the output current is equal to 0, or when the output terminals are open circuited. Like that, we have to write the definition, or we have to understand the concept. And similarly here, Z21 reverse transfer impedance. So define reverse transfer impedance. Then the reverse transfer impedance is defined as the ratio of the input voltage to the output current when keeping the input as a open circuit. Similarly, Z22 is equal to output impedance. Same way, and Z21 is equal to the forward transfer impedance is the ratio of output voltage by input current when keeping the output terminals as a open circuit. This is how we can define the various parameters inside the impedance parameters, right? Next, we will go to the Y parameters. Define Y parameters. So here Y parameters are also called as the admittance parameters. Of course, anyway, all the two-port networks are used to analyze the all the parameters are used to analyze the two-port networks only. And here the currents are represented as a functions of voltage. Just reverse. Before, the voltages are represented as a functions of current, but here the currents are represented as a functions of voltage. Or the Y parameters is a dual of Z parameters, because we have already discussed about the dual networks. Okay, so which means here the Y parameter is a dual of Z parameters. Then you can see how we can represent. Okay, so here I1 is equal to functions of V1 and V2, and I2 is equal to functions of V1 and V2. The same like in the previous case, V1 is equal to functions of I1 and I2. Here it is a two-port, or it is a the currents are representing as a functions of voltage. So that's why here we are representing I1 is equal to F1 of V1 and V2, which means the function of voltages V1 and V2. Then if you want to draw a two-port network in case of Y, to define the Y parameters, then this is the two-port network to define the Y parameters. Of course, everything is same, only just you need to represent here the currents in terms of a function in a functions of represented as a functions of the voltages, right? Then coming to the equations. Okay, so here I1 is equal to Y11 V1 plus Y12 V2, and I2 is equal to Y21 V1 plus Y22 V2, right? Then here, of course, the same way here. Now we need to find Y11, Y12, Y21, Y22. So first let us find Y11. Of course, these, okay, later I will tell you, okay, what again we can also call as other name of the Y parameters. Like in the before case, it was open circuit parameters. Like here also there is another name that I will let you know in the next step. So of course, the same way here we can represent this equation in terms of the matrix form. Okay, and here this is called as a the admittance matrix, we usually call it as. Okay, so if you will get a question like write the admittance matrix, then you have to write Y is equal to in a matrix form Y11, Y12 and Y21 and Y22. So this is called the admittance matrix. In the previous case, it was impedance matrix, right? Yeah. Yes. So these parameters are also called as a short circuited parameters. Why? Because by making the short circuit, by making the output as a short circuit, we will find the input side parameters. And by making the input as a short circuit, then we will find the output side parameters. So that's why these are called as a short circuit parameters. Okay, like in the before case, it was open circuit parameters. Okay, fine. Here also, Y11 is the input admittance. Okay, when keeping the output short circuited. So which means output short circuited is nothing but the V2 is equal to 0. The same case here, in this case, suppose in the first equation, if you make V2 is equal to 0, then here this will become I1 is equal to Y11 V1, because this whole term will become 0. Then here you just send V1 to the left hand side, then Y11 which means Y11 which is equal to I1 by V1. Yeah, this is what equation. So this is input admittance. Then coming to the reverse transfer admittance, Y12. So in Y12, now you have to make input as a input terminals as a short circuit. So input terminal short circuit, again we should use the same equation. Then in this case here I1 is equal to, if you substitute V1 is equal to 0, then this will become 0. Then here you will be having only the term which is related to Y12 into V2. So you just send V2 to the left hand side, then Y12 which is equal to I1 by V2. Yeah, this is this. Because if you understand the concept, then you no need to remember all these equations. Okay, directly you can derive by yourself by using, just you need to represent currents are represented as a functions of voltage. That's all. So then after that, you know how the currents can represent as a functions of voltage. So like this. So like these two equations. So from these two equations, then if you understand the concept, then you can easily derive or define the various admittance parameters like Y11 and Y12 and Y21 and Y22. Right? So you don't need to remember all these equations. So what is Y11, I1, V1, R, V1, I1, like that you don't need to remember. Okay. So just you need to understand the concept. Once you understand the concept, you just apply the concept. Then you can automatically derive or you can automatically define these parameters. Fine. Yes. Then now Y22. So Y22 here it is the output admittance parameters by keeping the input as a short circuit. Of course, in this case now we need to go for the second equation. In the second equation again you just make it V1 is equal to 0. If you substitute V1 is equal to 0, this total term will get 0. Then you just send V2 to the side. So here Y22 is equal to I2 by V2. That's what here they define. Right? Because here output admittance, because Y22, so both are represented to the secondary side. So that's why it is a, the output admittance. Okay. So in the previous case, Y11, so both are represented to the primary side. So that's why it is input admittance. Okay. Then Y21 is the forward transfer admittance by keeping the by keeping output short circuit V2 is equal to 0. So V2 is equal to 0. This whole term will become 0. Then send V1 to the left hand side. Then Y21 is equal to I2 by V1. So this is what the forward transfer admittance or Y21. The same way here also, if you get the question like define what is input admittance. So the input admittance is defined as the ratio of the input current by the input voltage by keeping output short circuited. Similarly here Y22, what is output admittance? The output admittance is defined as the ratio of output current by output voltage by keeping the input short circuited. That's all. Like that we can define the all four parameters in case of the admittance parameters. So here the Y parameters are also called as the admittance parameters and also called as a short circuit parameters. And why we are calling as a short circuit parameters? Because by making the input and output side as a short circuit, we are going to find the admittance parameters. So that's why these are also called as admittance parameters. And how we can represent these admittance parameters? It can be represented, which means in the admittance parameters, the currents are represented as a functions of the voltage. That's all. These are the only three concepts in case of admittance parameters. Then coming to the define ABCD parameters. Right. So in ABCD parameters, because we have already known, these are also called as a transmission parameters. Then here the voltage and currents are, and of course here the voltage and current and of input part are expressed in terms of the output part, which means the input parameters are expressed in terms of the output parameters, which means the V1 and I1. Before, of course, the voltages V1, V2 and I1, I2 like that, but here it is the input and output. Okay, once here I will write the equations, then you will understand. Yes. So V1, which means the voltage input parameter is defined or is defined as a functions of the output parameters. So input parameter here it is V1 is a functions of the output parameters V2 and I2, and input parameter I1 and is representing a functions of output parameters which are V1 and V2. Sorry, V2 and I2, right? So then, of course, the same thing you can represent as in a network form. So just you need to, what is that right here? These equations, the input parameters are represented as a functions of the output parameters. That is what the exact definition of the ABCD parameters. So these are also called as a transmission parameters. Then here, if you write these in terms of equation, then V1 is equal to A into V2 minus B into I2, and I1 is equal to C into V2 minus D into I2. So from this, then now we are going to find A, B, C, D. Okay, the same like in the previous case, this can be also represented in a matrix form. Okay, so here, or in another words, the same like here. Of course, here, because before it was, what is that, A, B, C, D, but this transmission line parameters can be represented as a T. So which means here this can be written as T into V2 minus I2. V2 minus I2. Right? So the same way, okay, now here we need to find A, B, C, D. So here A is nothing but, okay, if you want to find A, then you must make the I2 is equal to 0. Okay. So how I2, when I2 will become 0, when you will open circuit the output terminals, then I2 will become 0. So that's what here, to find A, so we have to make it I2 is equal to 0. So I2 is equal to 0 is nothing but the output is an open circuit. Then if I make I2 is equal to 0, then this term will become 0. Then you send this V2 to the left hand side, then A is equal to V1 by V2. That's all. That is what the A parameter, that is reverse voltage gain. Then second case, now you need to find B. If you want to find B, then what you have to do? You have to make it V2 is equal to 0. So when V2 is equal to 0, when the output is a short circuited. So that's what here they will do. So B is the reverse transfer impedance, okay, keeping the output short circuited. So which means in this case, okay, so when you can find the B here by making this V2 is equal to 0, right? Then here by making V2 is equal to 0, then this whole term will become 0. Then you just send B to this side, then I2 is equal to V1 by I2. This is the reverse transfer impedance. Right. Then next case, here C. C is the reverse transfer admittance by keeping the output is open circuited. Reverse transfer admittance. So how we can find? Of course, this is by using the second equation. So if you want to find C, then again you have to make it I2 is equal to 0, which means by keeping the output as open circuit, then this whole term will get 0. Then V2, if you send to the left hand side, then C is equal to I1 by V2. Then similarly here you can find D. So how we can find D? Again you have to make it V2 is equal to 0, which means then you have to apply the short circuit across the output terminals. Then so that this total term will become 0, then send the I2 to the left hand side, then D is equal to I1 by I2, which is called as a reverse current gain. The same way like in the previous cases, here also if they ask you to define what is reverse voltage gain, okay, or what is A parameter, then you can define the reverse voltage gain is nothing but, or is defined as the ratio of input voltage by output voltage by keeping the output as a open circuit. The same way the other parameters B, C, D also. Right. So this is how we can define the A, B, C, D parameters. Now define H parameters. So these H parameters are also called as the hybrid parameters. Right. So in these hybrid parameters, how we can define these hybrid parameters here? The input voltage is a function of input voltage and output current. Sorry, input current and output voltage. That's what here hybrid. Okay, so it is a kind of mixed. So here we are not defining. Here we are not taking whether the voltages are currents or the input side or output side parameters. So here we are taking a mixed kind of thing. So that's why we usually call it as a hybrid parameters. So which means V1 is a function of I1 and V2, and I2 is also a function of I1 and V2. Right. So when coming to the equations, so here we can write the equations like this. V1 is equal to H11 I1 plus H22 V2, and I2 is equal to H21 I1 plus H22 V2. Of course, the same way here also we can represent this in terms of the matrix form. So here this matrix is also called as a hybrid parameter matrix. right? So here h is equal to h11. Of course, sometimes they represent here it is small h also. So both are correct only. Sometimes they usually represent which means here h11 and h12 and h21 and h22. Okay. So in some textbooks they represent as a capital H, and in some textbooks they represent as a small h, but both are correct only. So we can take according to our convenience. But anyway, here I have taken as a capital H11 and capital H to represent the H parameters, right? The same way here also, suppose if you want to find the H11, then we have to make it V2 is equal to 0. So V2 is equal to 0 is nothing but the output terminal is a short circuit. The same way here, H11. So this is called as an input impedance by keeping the output short circuited. So which means V1 by I1 at V2 is equal to 0. The same way, if you want to find H12, then you have to make it this I1 is equal to 0. So I1 is equal to 0 is nothing but the input side is open circuit. By keeping input as an open circuit, then you will get V1 by V2, which is called as a reverse voltage gain, H12. Then the same way here, H22, here it is output admittance. Okay. So this is by using the second equation H22, then you have H22 if you want to find, then you have to make it I1 is equal to 0, which means input as an open circuit. Then similarly, H21, so if you want to find H21, then you have to make, what is that, V2 is equal to 0. So V2 is equal to 0 is nothing but you have to make output as a short circuit. Then you can find this H21. So H21 is the forward current gain by keeping the open circuit by keeping the output short circuited. So which is equal to I2 by I1 at V2 is equal to 0. So this is about the hybrid parameters, right? Then now what is the relation between these parameters? Of course, we can make the relation also. So this how we can relate the Z and Y parameters that we have already covered in the previous classes. So here I'm not going through in detail. Okay, just I'm trying to remind what is Y and what is the relation among these parameters, right? So that is I have represented here. Yeah, finally, this is how the relation between, not relation, okay, just I have summarized, okay, and also I have defined the various relations, which means here the Z parameters, how the Z parameters represented in terms of Y parameters, and how the Z parameters are represented in terms of ABCD parameters, and how the Z parameters are represented in terms of H parameters. The same way, Y parameters in terms of Z, and Y parameters in terms of ABCD, and Y parameters in terms of hybrid. And the same way, ABCD parameters in terms of Z parameters, and ABCD in terms of Y parameters, and ABCD in terms of H parameters. And the same way, hybrid parameters in terms of Z parameters, and hybrid in terms of Y parameters, and hybrid in terms of ABCD parameters. Which means, suppose if you know the Z parameters, okay, so by using the Z parameters, you can find all other parameters because you know the relation between the Z parameters and all other parameters, right? So first let us take only one case, right? Suppose you know the Z parameters, so by using the Z parameters, you want to find the ABCD and H parameters, right? So by using this relation, then you can find the Y parameters from the Z parameters, right? And by using this relation, you can find the ABCD parameters from the Z parameters. And by using this relation, similarly, you can find the H parameters by using the Z parameters, right? So this is how the interrelation between the various parameters in the two-port networks, right? So this is about the two-port network definition and terminology related to the two-port network parameters. In the next class, we will discuss the definition and terminology related to the graph theory, the another part in the module 5, because that is also very important. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.